Thanks for joining me in this session, State of Reactor 2019. So today I wanted to share with you what's been going on in Reactor the past year since the previous SpringOne, and what's new and what's going to happen in the near future. Anybody was at the last SpringOne in the State of Reactor session? Okay. Who here is completely new to Reactor, doesn't know anything about it? Okay. That's not necessarily the right session for you guys to learn about how to do reactive programming, but I hope you can still get some glimpses of interesting things. All right. So I think I have to put that kind of slide because I'm saying stuff that has yet to come and nothing sure about that. But what we'll do today, so the state of Reactor today is we have more or less 3 release trains active, or rather Bismuth was the previous one, and it has end of maintenance, end of life. Californium is the current one that I guess most of you are using, but it's now, as of the past month, basically reached maintenance-only state, because we just released Dysprosium, which is the brand new release train that was just released, 3.3.0 GA. And that's the one that will be behind Spring Framework 5.2 and Spring Boot 2.2. So today I'm going to look at that part of the timeline, what's been done in Californium in the past few months. And then we'll obviously look at what's new and shiny in Dysprosium. I don't know if you know, by the way, but these code names for the release trains, they are like alphabetical order elements from the periodic table of elements. And maybe some made-up elements if we are missing a letter, like unobtainium if we ever get to U, for instance. So yeah, we are gonna look at Dysprosium and what's going to come after that. So now in maintenance mode, Reactor Californium, that's Reactor Core 3.2, Reactor Netty 0.8. What's been going on since the previous SpringOne? We've been, for instance, doing continuing our work with do on discard support. So do on discard was this kind of advanced operator, advanced mode, where you could ensure that costly resources that you produce in a flux are correctly cleaned up, even in the case of a cancellation or an error happening in the flux. I'm thinking, for instance, byte buffers from Netty, because they are off heap and you have to explicitly release these. So that was kind of an issue. So we added this operator and more, or this mode of operations, and more operators are compatible with it. Since last year, there's also been some documentation-facing work, notably the diagrams. We switched from PNGs exported from a closed format to SVG, and that was a huge amount of work, like very boring work, but huge. But the idea behind this is important to you as well, because if you want to contribute, and if you wanted to contribute, for instance, like you spotted a mistake on one of these diagrams in the Java doc, it was a real pain to change, right? You had to add a proprietary tool. You had to submit the pull request without any way of previewing what it would look like. And then the PNGs in the Java doc were linked with static URLs to GitHub, raw GitHub content. So you had to release first, and then reference a commit, and then the next major release you would like update all these URLs to point to a tag because you didn't have the tag before the release. It was a mess. So now you can actually contribute changes to the diagrams. We added a new operator as well, or rather two new operators of note. Switch on first. The idea of switch on first is you have a flux. This flux has several messages, emits several messages, and the first of these messages is actually containing some sort of routing information. So you want to switch your processing depending on the content of that first message. That came very handy in the implementation of RSocket Java client, for instance, because in RSocket there is a typical use case for this operator is routing, right? And it looks like this in one of these SVG marble diagrams I was talking about. So here, for instance, you see that we can decide, depending on the first element, the color of the first element, we can decide to filter elements that are not of the same color that come after it. So we let pass the yellow one, the purple one, the blue one, but not the green one. So again, as always, these diagrams are a bit abstract, simplified cases, but they give you a good understanding, a good graphical view of what the operator is supposed to do. This is one of the most complex diagrams, I'd say. One of the, complex operators. So switch on first. We also added a do first operator. So I don't know if you're familiar, but we had for a long time a do finally operator. So the idea of do finally is introduce some side effect or some, for instance, logging, not processing. Don't do processing in your side effect operators. But we had this do finally that you could use to react to a completion of the flux, but also the cancellation. So if you want to do something every time there is any sort of termination of the sequence, you could use do finally. But we didn't have really the reverse. And a lot of people thought that do unsubscribe was the one to use. And then we had a few issues open, like, hey, I used do unsubscribe, and the order of my logging messages is not what I expected, because there is a small twist to do unsubscribe. So do first is much more explicit. It's really the first thing that ever happens in a reactive, in the reactive sequence that you put that in. So you have do first as a nice duality to do finally. Looks like this. So whenever you subscribe to this flux, it will execute the side effect of do first, and then propagate the subscription, which in turn will trigger an unsubscribe event from upstream to downstream. And then once you have the unsubscribe, you have a hold of the subscription object that lets you request items and also lets you cancel the sequence if needed. So this is the difference with do unsubscribe is it happens here before the subscribe signal, whereas the do unsubscribe would happen here. So you have a subtle difference, but it can get things out of order. So that's since 3.2.10 release that you have this operator. We've also added a few checks in the same versions, 3.2.10, around the context. So the context is this little object that can be passed around, or rather reached from different stages in your asynchronous pipeline, in which you can, around subscription, you can put some data like a correlation ID or something like that. And when the data flows into the pipeline, you can get access to these elements that are specific to a given subscription. But the context was supposed to be immutable and was supposed to hold no duplicate and no null, except it didn't really check for nulls. So now it does, and now it actually also checks for duplicates, duplicate keys that you could get in some corner cases. And we've eliminated these corner cases. So yeah, a few quality of life, a few new operators during this, I think there's been like 4 releases or something like that of Reactor Californium since last SpringOne. And so we've added these elements. And of course, all of these are, even though they've been developed in parallel with the milestones of dysprosium, they, of course, go into dysprosium. Newly released as of last 2 weeks ago, dysprosium. What's with the name, by the way? Dysprosium means hard to get. Sometimes reactive programming is hard to get too. That's a rare earth element. It's used in nuclear reactors, so pretty good link with Project Reactor, right? It's also used for hardware for data storage, long-term data storage. So yeah, I thought it was kind of cool. That's these tie-ins to what we do in the programming space. So it's made up of reactor core 3.3 generation, NETI 0.9, reactor add-ons 3.3 as well. Add-ons is for like these extra operators that we don't think are that mainstream, or maybe for kind of beta operators. And there is also a new addition to the family with reactor-pool 0.1, and we'll look at that at the end of this talk. So what's new in reactor 3.3.0? We tend to do that with new release trains. There are a few deprecations, so I wanted to give a heads up for you about that. Notably, the work queue processor and topic processor are being deprecated. That's because they use under they use unsafe operations. And this tends to be more and more problematic with new releases of Java, where they are phasing out some of these capabilities associated with the unsafe class. So yeah, we think that unsafe will go away completely, and then these two processors won't work anymore. So we have a few alternatives. For instance, you can do something pretty similar to topic processor with a publish on or chaining different operators. And we'll probably, once we completely get rid of this, we'll probably have some sort of alternative in place for you to switch. Kotlin extensions also have been deprecated. They are actually moving out of core and add-ons to their own artifact, to their own repository, Reactor Kotlin extensions. So you will still get access to Kotlin extensions for Flux, Mono, all that. It's just a new artifact to import. That's the only difference. Some overloads of using when also were a bit problematic, so we've decided to deprecate this to be able to fix the API. And it's the same with mono after success or error. There is also one behavior change. These three operators were actually had corner cases where they would produce a publisher that didn't respect the mono contract. The mono contract is at most one on next signal, so one element emitted, followed, either you emit on next, on complete, and that's it, or you emit nothing, you complete, and that's it, or you emit an error, and that's it. And these operators are at corner cases where you could have an on next combined with an on error, which is not supposed to happen. So these have been fixed, but it's important to keep that in mind. Compose also have been deprecated. It's being renamed to transform deferred. A lot of people don't know about compose. They see transform, which is a way to apply a function to an existing pipeline, where you want to mutualize code to apply a bunch of operators to a given flux or a given mono, and you want to be able to reuse that logic, like add logs or add, authentication to a request or something like that. And sometimes you need to do that in a deferred fashion. And what we usually mean by deferred in Reactor is that instead of doing that when you instantiate the flux, which is a lazy construct, you do that when you subscribe. When we say defer, we basically say a different behavior for each new subscription to the same flux instance. So sometimes it doesn't really matter, but sometimes you want to do something very specific to each subscription, not only one flux, but every time you subscribe to that flux, and you could subscribe multiple times. And also, the big one, the big new feature of this release of Dysprosium, or Reactor Core 3.3 rather, is the new bounded elastic scheduler. Bounded elastic is a way to have a thread pool that will grow with your needs, that will cache the threads. So that's basically what Elastic is actually at the moment, sorry. But there is one big issue with that, is if you offload blocking work to that existing Elastic scheduler, and you do that a lot, you end up creating a lot of threads. So the idea of Elastic scheduler is it grows indefinitely. Each time you submit a task, potentially could create a new thread. And then once it's not used anymore, the thread goes back to the pool. It has a time to leave. After 60 seconds, it will be destroyed. If there is a new task within that time frame, it reuses the thread. But yeah, you could come with a case where it creates like 2,000 threads. And that's not a good thing to have in an application. Usually it means that you have some blocking work and you've learned about the Elastic scheduler and you think, okay, I can offload that blocking work to a different scheduler, and this way it won't block my asynchronous processing. But we think that with the bounded elastic variant, it actually makes sense to put a cap to that, the number of threads that the elastic scheduler can create. So with bounded elastic, we have an arbit. Yeah, it's still to be determined, but there is a default cap on the number of threads that it can create. And then there's also an option to make it enqueue further tasks indefinitely, or also put a cap on the number of tasks that it can put aside until there is a thread that is ready to do the work. So what it would do if you submit, say you configure it to create no more than 10 threads and then enqueue no more than 100 additional tasks. If you have 105 tasks, it will create the 10 threads and then enqueue the additional tasks, no problem. Once the initial tasks are done, the threads go back to the pool and steals the work that you have previously enqueued and until it has run all the tasks. But if you submit much more than that, you will get basically rejected execution exceptions. So you will be able to say to your users, okay, now I am really under a lot of pressure and execute different code path to deal with that, rather than crash the entire VM because you have created way too many threads. Another change that was briefly shown by Sergey in the previous talk, improved backtraces format. So when you start with reactive programming, you realize pretty quickly that the good old stack trace is not that useful anymore. And so we had some thinking around that, and we came up with the debug mode, where when you instantiate when you call an operator, we'll kind of instantiate an exception and capture the stack trace. And later on, if there is an error that traverses this operator, we will be able to show you the stack trace of where you actually called that operator and not where it was subscribed. And the issue is when you come across such an exception, you get the like the vanilla stack trace that basically points you to where you subscribe to that flux, and usually it's not very interesting. Sometimes the first 2 or 3 lines are interesting, and they allow you to point to like a lambda or something, and then okay, that's the problem. But in the other cases, you don't really care about all that stuff. And then with the debug mode, we add at the end we add what we call the backtrace, so an additional small stack trace that shows where that operator was called. That's called assembly time. And most of the time, that's the lines that you care about, right? So now with improved backtraces format, we kind of artificially suppress the vanilla stack trace. We replace the stack, basically the array of stack frame elements, with the one from our backtrace first, and then we put the original vanilla stack trace at the end. So we kind of invert the presentation of the stack trace so that you can read it more naturally, like you're accustomed to. And of course, there is like a message that says, okay, this stack trace has been moved around artificially. For those of you that use Java 9 modules, who uses Java 9 modules? Okay, so for you guys in the back, now at least all the artifacts in Project Reactor declared a Java 9 module name. So it's not modularized, but at least if they change the automatic name generation or anything like that, the name is stabilized. Okay, and there's also some quality of life in the step verifier for the tests if you want to represent some objects in the error message, but that's a very small change. Reactor Neti 0.9 is mainly about performance improvements. We've seen some tweets, people switching to this version and getting 30–40% increase in some specific cases in performance. Also, it takes the it uses reactor-pool, the new reactor-pool project, shaded version so that it doesn't expose it to you for connection pooling. And it added some features like proxy protocol support, TCP, HTTP metrics, integrates with BlockHound. There's also a new reference documentation. So the reference documentation didn't really exist for reactor-NET so far. So we've added a reference documentation that is more complete, more in line with the one you could have in core. And there are some small API adjustments. But I wanted to talk about reactor-pool as well. And I only have like less than 10 minutes to do that. It's still early, first release of the project, 0.1.0. The API is, we believe, stabilized. The idea is good old generic object pool, but without blocking at any step, without blocking operation when you acquire an object from the pool. So you have an acquire method to get an object from the pool, and you actually get a mono instead of the object. You don't block for the object. A mono of what? A mono of pooled ref of a resource. What does that mean? So the resource is your actual object, a connection, byte buffer, whatever. And we added an indirection, a layer in the middle, pooled ref, which represents slots in the pool. And it gives you access, as a result, it allows to have access to metadata, like how long this object has been live in the pool, how long has it been idle, that sort of thing. And also the reference, the pooled ref, is the construct that lets you release the resource. You create a pool with a pool builder. You start with an allocator. It's a mono that produces a resource every time it's invoked. You configure what we call allocation permits, which is basically the limit of the number of objects that you can create through the pool. You configure how to recycle via a release handler, which is also a mono. So every step of the way, it's monos and flux. So it's all wired to be asynchronous and non-blocking. So you have to have that sort of methods to construct your object in a non-blocking fashion. You configure also an eviction predicate. So basically a way to test if an object, once you release it, goes back to the pool, is recycled or is destroyed. And when it has to be destroyed, how do you destroy it in an asynchronous fashion as well? And then you can do some fine-tunings, clocks, metrics, limit the number of pending acquires, etc., on which scheduler do you want to publish, extra configuration. And at the end, you choose a flavor between FIFO and LIFO pool. So first object that was allocated is the first out, or last used, first out. So what's the resource lifecycle like? Looks a bit like that. So you allocate an object, you recycle it, or you evict it, and then at the end you destroy it. And when you allocate, it consumes an allocation permit, and when you destroy it, it restores an allocation permit. So if you have at least one allocation permit, it can, and you can call acquire, and there's no idle element in your pool, then it will allocate a new instance. So you call acquire. It invokes the allocation handler, which is a mono, and that consumes an allocation permit. You use the returned object from the pool, and then through the pooled ref, you release it. It's dirty. You invoke the release handler, which will clean it up. Say you have some state in your connection or some prepared statement in your DB connection that you want to clean up, you can do this in this phase. And then it will go through the eviction predicate to say, is it still in a good state or it's in a bad state, like it's too old or something like that. If it's in a good state to be reused, then all good, we put it back to the pool. And if there was any pending acquire, then these monos will then get served. And you can use it again, extra, release it again, clean it again. Or if it's at the eviction predicate stage, if it's in a bad state, which you could control through the metadata on the reference, you could say, okay, if it's been recycled 10 times, or if it's been idle more than 10 seconds, then I want to get rid of that object and allocate a new one. So if that's the case, then simply put, the object is in a bad state, it gets evicted, and the destroy handler is invoked. And once again, the destroy handler is also a mono asynchronous processing of that resource. So this will not block your application that uses the pool. And then you get a permit. Atomically, you get a new permit restored to the pool. So what if there is no allocation permit that remains? What if when you acquire, the pool says, hey, you told me like no more than 10 objects creations. So you do a first acquire, it allocates and emits that resource. A second one, and then you reach the limit, which was 2 in this case. You do a third acquire, the mono will be in a pending state. So since you obtain a mono, it's all lazy, right? And it doesn't have to return immediately or block. So you can compose a pipeline that uses this mono, and the pipeline won't get kind of realized until the pool, an object is released back to the pool and gets ready. So even if you do a fourth acquire at this stage, the returning mono will be pending, and you will not receive a resource just yet. Then on the first acquire, you finally use that resource and you call release. At this time, it will immediately return the object back to the pool and trigger the onNext on the first of the pending monos. So yeah, that's pretty simple. And it works really well because at each step we are dealing with monos. We are not dealing with the resources, the connection, or the byte buffer. We are dealing with something that you're already accustomed to, that represents kind of an idea that in some point in the future, a resource will be available. And immediately, as this resource becomes available, is emitted through the mono, it will flow through your pipeline of processing. And then, of course, at the end, you have to kind of release it, but you can do so with using when operators that are already available in Reactor. Very briefly, what's next? No promises, but we want to work more on the context. We want to work on macro fusion, this idea that similar operators, when you do map, could be fused together and only result in a single map instance, since it's functions that are already composable. 3.4, codename Einsteinium or maybe Europium, we have not decided yet. Go vote for a name. Yeah, that's the next big one, 3.4. We want to add maybe a state machine operator. That could be interesting. We want to add also probably a source polling operator, so a way to poll more classical source or like something like paging, that sort of stuff, with a baked-in operator that converts it to a flux. We want to work on blueprints as well. The idea with blueprints, or the early stage idea, is that we want to pre-assemble pipelines in the context and then feed them with a source last minute, which would avoid some instantiation. Something that we've put aside for a bit, but we still need to improve the processor APIs. It's still too easy to shoot yourself in the foot while using the processor because the API is not that good at showing you the right way of using it. So we need to improve that. Reactor native 1.0, at some point we will have to release the 1.0, right? So we've been waiting for it for a bit. And probably also more tools to write operators. That's maybe something that could go hand in hand with Project Loom when it's released, because I can see Project Loom as a way to actually support reactive programming and the internals of reactive programming, and ease some of the use cases when you want to write your own operator. But having this composability of operator is something that will stay beyond Loom, in my opinion. Re-architecture operator internals. And yeah, custom demand or prefetch management is another topic that we'd like to explore, but it's further away, probably. I don't think I have time for questions, unfortunately. Sorry, I went a little bit over time. Thanks for your attention, and I'll be available for questions here.